Hopefully you guys can see. All right, so we are going to talk about air masses and fronts. Now, air masses we have actually been talking about already. When we did jet streams, right, I stopped the movie and I talked about the symbols that were on there. So guys, on your desks right now or wherever you are, you need page 13 of your reference table out. Whether it's on your iPad and you want to do a split screen, I'm going to be going back and forth, or if it's the hard copy. We're not writing on it, so I just need you to have it out. I'll give you guys a second to do that. So air masses are these, right? They're the ones where it was C for continental, M for maritime, right? So C for continental, M for maritime, right? It's just a matter of where it was coming from. And then you have Arctic and polar when it comes from the colder parts of the Earth, or tropic and equatorial when it comes from the warmer parts of the Earth. So if it comes from the very top north or the very bottom south, it's considered polar or Arctic. If it comes from the middle of the Earth, it's considered tropical. Okay? All of the symbols that you need to know are on page 13, the bottom right-hand corner, or right in the middle. Okay? What do you need to know? Well, if it's continental, it means it's coming from the land, right? And here's the thing, if it's continental, it's always going to be dry. Okay? If it's continental, it's always going to be dry. Right? If it's maritime and it's coming from water, it's always going to be moist. So it's going to have some sort of wetness to it. That makes sense, guys, right? If it's continental, coming off of the land, it's going to be drier than something that's coming off of the water, right? Then you have Arctic and polar, which for this level of earth science means the same thing. If you go to college, or when you go to college, and you have to take a science class, if it has a meteorology program in it in any way, shape, or form, they'll get into more details as to what the difference is between polar and Arctic and tropical and equatorial, okay? But for your purposes, Arctic and polar mean the same thing for this level, okay? And tropic and equatorial basically mean the same for this level. Technically, at this level, the equator version of it doesn't exist. If you look at the reference table, the equator one is not even there. So they're assuming, excuse me, that if it's coming from the equator, that it's tropical, which means that it's going to be hot or warm. Okay? If it says tropic, it means hot or warm. Okay? And if it's polar or Arctic, it means cold. Technically, Arctic means that it's even colder than polar, but again, for this level, you just need to know that they're both coming from the cold, okay? Technically, what's north of us, guys? Geographically, what's north of us? Canada. Right now, if you were to look up on your weather app, Canada's weather, is it going to be warmer than us or colder than us? Colder. It's going to be colder than us, right? So cold air will come down from Canada to us. It'll actually be continental polar because it's coming from the continent. You didn't have to come over any sort of water. Do you see how that works? You guys okay with that? Okay. So let's see if that actually works because it didn't this morning. The computer's just being slow. Nope, it doesn't work. Okay. All right, so here's just a review. You do not have to write anything down. Okay. Really quickly, when you have a low pressure system, right, you know the lowest pressure is going to be at the center. You know its nickname is a cyclone because it starts small at the bottom and works its way up to a bigger circle in a counterclockwise fashion. We know this, right? We know this is what it looks like, right? We know this is what it looks like. What's the other nickname for low pressure systems that I gave you? L stands for low, but it also stands for what kind of weather is going to be around a low pressure system?
Lousy.
Lousy, which means what kind of weather is that if it's lousy?
Rainy.
Rainy, thunderstorms, all that fun kind of stuff, right? Versus high pressure systems, right? They're the anticyclone because it starts small on the top. It moves in a clockwise fashion and down and out at the bottom, right? And it's represented by an H on the weather map. Now, when you're looking at this, okay, it always moves from high to low, okay? Depending on how the jet stream is moving, we've talked about this, but depending on how the jet stream is moving, right, it should move in this general direction. So right now, the jet stream has dipped down last week, which is why we had those extreme cold temperatures. But now it's moved up a little bit, which is why we're getting warmer, springier temperatures, okay? So let's go into what a front is. And again, if you're following along in the review book, it's pages 145 to 146. Okay? With fronts are what actually bring the weather in, right? And it's when these different air masses are going to come in contact with each other. So if you have a continental polar air mass that comes in contact with a continental tropic air mass, you're going to form a specific front. And yes, I will get into what each one of these four are. All right? And they are the warm front, a cold front, a stationary front, and an occluded front. And if you look at the bottom right-hand corner of page 13, there are symbols that go with it, with each one of those types of fronts. Now, this is one of those topics that you have to see happening to really understand it. So what I'm going to do is, I have 2 short video clips, okay, throughout this lesson today. I'm going to have you guys watch them and draw what each of the symbols and the fronts look like in your notes. So I'll be stopping it, and we'll talk about it as it goes on, okay? Everybody at home, you good?
Yeah.
All right, cool. All right, so I'll tell you.
To a caricature artist, everybody's
draw
unique.
down and everything.
Liberty Mutual thinks so too. They customize car insurance.
Love
so you only
commercials
pay
as much as I do.
Spiky lines, red bumpy lines. We see these on our weather maps all the time.
Okay, so those little, you won't have to draw them down, but I want to show you really quick. These are the symbols that are located at the bottom right-hand corner of page 13. Okay, they mean warm front and cold front. You'll also notice that they're in red and blue in color on the weather map. Okay, on your test and on your reference table, they're not in color. It's just like the cold current versus the warm current. Okay, so you're going to be responsible to be able to identify what kind of weather pattern is coming through.
We see these on our weather maps all the time. But what are these fronts, and what do they mean for our weather? As the atmosphere flows around the planet, it tends to do so in large air masses, each of which has fairly uniform conditions of temperature and humidity. It's at the boundaries between these air masses that we find weather fronts. If
Okay.
a cold, dry air...
So basically, did you hear what he said? It's where the two meet. That interface is what a front actually is. So what I would do, guys, is here's a cold front to start. I want you to just copy down the circle with the little triangles on it and how you have the warm air going towards it and the cold air coming this way. Okay? Notice that the cold air or the cold front that is going to be created is represented by those triangles. And the direction in which those triangles are pointing is the direction in which the front will happen. Okay? Now I want you to think about it. You have cold air and warm air. What do you think is going to happen? And I will say, think about it on a molecular level. On a molecular level, what is happening to the cold air molecules versus the warm air molecules? What's happening on a molecular level, guys? Exactly. The warmer molecules are moving faster, which tells me what? They're moving faster. What happens? Want to continue? They will rise, right? But the one part that you missed, the little step in between, is that because they're moving faster, they move further apart, which makes them less dense, right? If it makes them less dense, it allows that cold air to go underneath it, lifting the warm air up. What did we talk about yesterday happens when warm, moist air lifts up? Not convection. Well, sort of convection, but what gets created? Did a whole lesson on it yesterday. What? Clouds. Exactly. So watch what happens.
Air mass pushes into a warm, humid air mass. We have a cold front. And as the colder, denser air advances, it forms a steep wedge that forces the warm air in its path upward very quickly. Clouds form right at the front. This typically produces very abrupt, sometimes very intense active weather. If a warm...
Okay, so look what he said, right? First of all, let's just bring you back a little bit. Notice that it's a steep rise. That warm air is going to rise up super quick, okay? And that rising up super quick is going to give us that dangerous type of weather, that weather that comes in hard and fast, right? And all of a sudden you get a thunderstorm out of nowhere, or seems like it's out of nowhere. Okay, and it's more dangerous. It's because of the fact that the warm air has such a less density compared to the cold air. So when it comes in, it's like, whoop, you got to go up, right? So it goes, whoop, right? So that warm air rises over it, which creates the clouds and a very quick storm that's also very dangerous. Okay? The cold air is more dense, which is why it stays lower.
Very quickly. Clouds form right at the front. This typically produces very abrupt, sometimes very intense active weather. If a warm, humid air mass...
Okay, before we actually do this is a warm front. Okay? A humid, warm mass moves in. When it moves in, notice the steepness is much more gentle. The slope is much more of a gentle thing. So this isn't going to happen very quickly. This isn't going to be as intense as a cold front. Another thing you're going to want to notice is this half moon pattern. Okay? That half moon pattern is pointing to the right, and therefore the whole front is going to be created as it moves to the right. Okay, so a warm front is when warm air comes in, right? Then let's see what happens.
Pushes into a cool, drier air mass. We have a warm front, with warm air overtaking cooler, denser air. The warm air is forced upward, but at a much gentler slope than with a cold front. This produces widespread cloud and precipitation.
Okay, now notice what he keeps saying. It's warm, moist air, right? Is coming in contact with cool, dry air. So you're going to have a maritime tropic air mass coming in, right? And it's cool and dry. So what kind of air mass is that if it's cool and dry? Guys at home, what do you think? If it's cool and dry, what kind of air mass is that?
Stationary.
No, air mass. What we did before that. Before we started fronts.
Maritime.
Wait, hold on. You're saying maritime, you're saying?
I said continental also.
Okay, so we're saying maritime versus continental, right? Well, let's think about it. If it's continental, is it going to be wet or dry?
Dry.
It's going to be dry, right? So we know this is going to be continental. And if it's cool, are we talking about tropics and equatorial, or are we talking about Arctic and polar?
Arctic.
Arctic and polar, right? Polar.
Along the front and just ahead of it. And as the warm, humid air flows further up that gentle slope, it results in mid-level clouds ahead of the active weather, cirrus clouds far out in front. We don't necessarily need moving air masses, though, if there is an abrupt boundary between two air masses, but neither is intrusive.
Okay, so a stationary front. Look at the symbol. It's when a cold air front and a warm air front are hitting into each other. So their symbols are going in opposite directions. Okay, so you have cold air and warm air basically colliding head on, but staying there. They're both fighting, but neither one of them is winning. Okay, so you can see that the cold air is coming in from the left because the arrows for the cold front are pushing towards the right, whereas the warm air is coming in from the right to the left because the half moon is pushing to the left. So let's see what happens.
Rooting into the other space, we have a stationary front. This can result in the same kind of weather associated with a warm front,
So it has,
which can last.
it has the same type of weather as a warm front. The difference being this could last days or weeks. Okay, because it just depends on who ends up winning. So those rainy weeks that we get, right? You know, sometimes where, especially in April and May, we'll get more rain over a long period of time. It's usually because there's a stationary front that is there.
For much longer, sometimes for days at a time. And finally, there's the case of the occluded front, where the fronts themselves push into one another.
Okay, so this one is known as an occluded front. An occluded front is when you have cold, warm, cold. Okay, so you have the cold front and the warm front happening at the same time. Whereas with the stationary front, you had cold air and warm air masses meeting. Okay, this one is you have your warm front over to the right here, and your cold front is coming in. So you have both fronts happening at the same time. And if you look, the occluded front symbol, right, has both the warm front and the cold front symbols in the same direction. Okay, so a cold front symbol is the triangle. The warm front is the half moon. The stationary front is both of them going in opposite directions, and the occluded front is both of them just going in the same direction. Okay, so for occluded fronts, you have both a warm front and a cold front happening at the same time in the same direction. That's the biggest difference between a stationary and occluded. Right.
As a fast-moving cold front overtakes a slower-moving warm front. As the two fronts meet, the warm air between them is pushed upward, but the denser air behind the cold front also wedges the cool air ahead of the warm front upwards too, lifting the entire boundary between cool and warm air completely off the ground. Due to the combo of cold front and warm front conditions, this often results in a combination of the weather for both as well, producing active, sometimes severe weather along the occlusion. So this wraps up season 1.
Okay, so you heard what he said. It sometimes can be severe weather because of the fact that you have both the cold front and the warm front happening at the same time. Okay? All right. Any questions on that? All right. Okay, so let's talk about, what time is it? 11:27, we have till 11:40. Yeah, let's talk about weather maps.
Good morning, everybody. I'm meteorologist Ryan Davidson.
Just ignore him. He's apparently related to somebody who was, when they did this video in class, this was made for his cousin somehow. Okay, so you just ignore what he's saying here. But what he's going to basically show you is when you are looking at weather maps, what are you looking at, right? Because remember I said every day you guys should be going home and watching the weather for 5 minutes. Just one weather segment, right? And if you have been doing it this whole time, little by little, you realize I know what they're talking about, right? It starts to click. So let's look.
actually Elizabeth's mom's cousin, and I work here at the Weather Channel. And I hear you guys are learning about weather. So we're going to talk a couple of things about weather systems and fronts and how those all come together to make weather. And then we'll talk a little bit about your forecast. So first off, we're going to talk about understanding what goes on in a weather map. So first, we've got cold air, and as it pushes further to the south, along the leading edge.
Okay, so notice where the cold air is coming from. It's coming from north of us, right? Because we said north of us, and I think they're actually in Raleigh, North Carolina, which is why he's showing it specifically in this area. But just so that you guys know, the cold air is coming down from Canada. It's coming down from the poles. But notice where you are going to see the actual cold front symbol.
Edge of where that cold air is advancing.
Okay? It's right on the edge. On the Weather Channel, or when you are watching the weather, they will not have this blue section that says cold. The only thing they will have is this blue line with the triangles on it. Okay? And you are to know that because they're pointing in this general direction, okay, the cold front is moving in this way. Okay? That's what you're going to have to be able to say.
Is where we would set up a cold front. And that's going to be this blue line here with all these triangles. And they point in the direction the cold front is moving. Now, on the other side, we have a warm front. We have a mass of warm air moving northward or in any direction. The leading edge of that warm air mass is where we draw this warm front, which is going to be the little red line with the half circles.
Did it like 4 times. Okay, but notice that that warm front is coming from the south of us, down by Florida, down by the Caribbean, down by the tropics, right? Which is what you expect, right? And that warm front is coming in from maritime, so you're expecting it to be wet. You're expecting it to be moist air.
Best way to remember it is they're like little half suns, but they're always denoting warmer air. You kind of work it out that way with sun, warm front, right, like that. So that's how we denote where a warm front lays. Now, when we start moving and adding in things like pressure systems, we have a low pressure system right here. Air around the low pressure system moves counterclockwise and inward. So when we start putting those air masses around that area of low pressure, we begin to see just a few things happening here. The warm air surging northward, that's where the warm front is.
Ah. So you see, this is what you're going to have to decipher. That low pressure is right here. You have the cold front moving in this direction at the same time that the warm front is moving in this direction. So you would assume, because it's low pressure, what should be happening? What did we say at the beginning? Low pressure, the nickname is? Lousy, right? So if it's lousy, what would you assume should be happening right at these fronts?
Bad weather.
Bad weather. Well, what do you mean by bad weather? Some sort of a rain. Right. So watch.
The cold front surging southward, that's where we line up that cold front. And then we zoom in closer where we get all the precipitation. What's going to happen here is you've got this air coming down from the north and this air kind of going towards the north and east. What happens is this piles up as it gets.
Okay, so see how it says, I didn't even touch the board that time, that was creepy. Okay, see how it says convergence? Convergence just means that they're coming together, okay? The places where they are meeting is where you're gonna have that rising air. That's what this means, right? So this cold front this way is meeting with this warm front, and rising that air up. So right here, you would expect, right where that blue line is, you would expect there to be some sort of precipitation and some sort of cloud covering, because it's where the cold front is meeting the warm front, or the cold air is meeting the warmer air, which we just learned is a cold front, right? Where it's going to sharply push up the warm air, and that's how you're going to get your extreme weather. Whereas over here, where the warm air is meeting up with the cold air, you're going to have precipitation as well, but it's going to be more gradual. It won't be those thunderstorms.
That's close to this warm air mass, and it starts to lift. So where these meet, all that wind meets, we call that convergence, the meeting of air. When it happens, it starts to go, it has nowhere to go, so it has to go up. Once that starts going up, that's where we start to get clouds and rain. Usually along the cold frontal side of the storm is where we'll see things like thunderstorms. But on the warm frontal side, over to the north, that's where we'll start to see just broad air.
So you're still getting precipitation at both locations. It's just when the cold, that's a really weird face. As the cold front comes in, that's where you're going to get your extreme weather, because you force that warm air up so quickly that it doesn't have time to slowly come out. It's very violent. Violent just means like thunderstorms.
Areas of rain and showers and cloudiness. And as that comes through, well, the weather gets a little bit cooler. Now, high pressure, a little bit different. High pressure systems, air goes clockwise and outwards from the area of high pressure. So why don't we ever see any rain or anything near an area of high pressure? When you have all of this air moving outwards, it's actually like if you were going to turn the hose right on the ground. What happens is that water goes down and it spreads out. So you don't have any lift. So you don't have anything to create that upflow of moisture to create any precipitation. So usually when we talk about high pressure, we talk about nice weather. But let's take a look at what your forecast is looking like as we go through the next couple of days. We're going to be looking at a little bit of rain. We've got a couple of fronts to the south. Here's our warm front.
So look, right? Notice how it says moist air, because it's coming from the ocean. It's coming from water sources. So those air masses are going to be wet. So it's going to bring that. It's also going to be tropical because it's coming from the south, right? There's an area of low pressure here, which tells me that there's going to be some rain here, and there's going to be some rain here because it's lousy low pressure.
Front, see the red with the half circles. That's going to come northward. We're going to see a little bit of rain in eastern and central North Carolina as these low pressure systems and their cold fronts and warm fronts move along the eastern seaboard. Then by Wednesday, we'll see maybe a little bit of rain in Raleigh, but it quickly moves out, and we start to see some high pressure move in. How do we know? Well, we don't see any weather going on here by Thursday, and that will stay the same even as...
You hear what he said? How do we know what high pressure system came in? Because there's no more wet weather. Right now, is it supposed to rain outside? Look at your weather apps. Go ahead. When are we supposed to get rain? Or some sort of precipitation? When are we supposed to get rain, guys?
Saturday?
Like Saturday, it says oh God, Saturday and Sunday, it's supposed to be 100% precipitation, right? So right now, are we sitting in a high pressure or a low pressure system? Hi, how do you know? Because there's no crappy weather, there's no precipitation. So we're sitting in a high pressure system right now because there is no wet weather. However, what is moving in? A low pressure system, because for us, by Saturday, we're supposed to be getting rain. Do you guys see that? So it's a couple of things that you learned today. One is the air masses, right? Depending on if a continental polar air mass is coming in, it's not bringing any rain with it, so it's not moist. However, if it's going to hit a maritime tropic air mass, it's going to create those showers, and that's a cold front. So you learned it's a combination of everything. You also learned that if you go from high pressure to low pressure, it's going to follow the same flow. Okay? Right? So at pretty much all of those fronts, you're going to have weather. It's just a matter of, is it going to be extreme weather or not? Okay, so you can watch the rest of
As
this.
we head into Friday, things kind of clear out. So the next weather system comes on in, and we start to see some rain heading in portions of western Tennessee and portions of Mississippi. So here's what comes up for Raleigh over the next 5 days. We've got rain on Wednesday, and a little bit cooler, notice, as we get that cold front to come through, brings that rain, 48 degrees. Then we warm up, and high pressure moves in. We get sunny conditions, and our temperatures kind of get back into the middle 50s. Then we get really nice by Sunday with a temperature of 63 degrees.
Well, aren't you special? You guys get nice weather, right? So do you guys understand that? Like he said, there's a low pressure system that's coming in on Wednesday, which is how you are getting the rain on Wednesday. And it's also a cold front, which means that it's going to bring colder, wet weather, right? Then a high pressure system moves in here, right? Which is also increasing the temperature. Okay, so when you track an air mass, right? It's always going to move from west to east. Anytime that you track air masses, it's going to move from west to east. And it should make sense to you because I've been telling you specifically, right, that weather typically moves southwest to northeast. Well, depending on which way or where the jet stream is, right, and where those prevailing winds are coming in, it's also going to affect the air masses, right? So they typically move from west to east, and we know that weather on average moves from southwest to northeast. It depends on those prevailing winds and how that jet stream is. During the winter, that jet stream is further down south, which brings that colder air down, right? Because in our winter, which is right now, there's less insulation that's coming in. Okay? That makes sense, guys? It's a lot of information, but what you really need to understand is that high versus low, what it means for the fronts, and being able to predict where it's going to be raining. Okay? Make sure you can look at a map with some fronts on it and understand where can you predict that it's going to be raining. Okay? So here's the practice problems that I want you to work on for tonight. It's 8 practice problems. Okay? Tomorrow, not 100% sure what we're doing yet. Okay, but I will post this along with this video for you guys. Have a great day, guys. Be good.